Hello? Mm, 1 second. Just have to do something real quick. All right. Hello, hello. And I work on cast today again. All right. So yesterday I did the fields, right? To be understandable by the LSP. Actually, so like if I do this std.prelude.print, right? I can go to the prelude here, go to the print here directly, and I can go to the std. But I just noticed that I cannot do it over here in the use std prelude, like, because this would be really nice also. That should be a really easy thing to do. Let me figure out why is that. It's probably because I'm not traversing it. Expression use dot star. This thing, I have a used expression, yes. Okay, so then in the LSP common, I think, I have a thing which is called inner compiled with handler. So when I have use dot star, wait, no, I am actually handling the used expression. Okay. So okay, I think what we can do is I can try doing this cast compile examples hello, right? This is right now defaulting to OCaml. So if I do target IR, no, cast CLI compiler. We have output type, not target. Right, so we do output type IR, which must be specified right now before the file, I think. Okay, there we go. So this is what our code compiles to. We have use.star, where used is a const. That's right. This means that I lose the information. So this is the constant, which is the standard library basically here, right? Makes sense. What I want is I guess it's when I'm compiling. It's probably the core syntax where I have use dot star, this thing. What's happening here? So we have this used expression, which I just evaluate, and we have the used expression, and we have this as part of the evaluated expressions, actually. Okay, wait, it does mean that I should be able to hover it though, right? Next, man, back to casting, yes. Hello, hello. So I'm working on LSP improvements. Specifically right now, I want to be able to hover over here. So I'm hovering use std prelude, but it's actually hovering the entire thing instead of hovering just std or just std prelude, and I cannot go to the definition here. Even although I can, if I do this std prelude, then I am able to actually go there, but not here in the use expression. LSP common. Okay. There is evaluated expressions and their handle expression. Is making the LSP hard? I would say it's not that hard, but I think I'm doing it differently than like a lot of existing programming languages, because basically in every single LSP that I have used myself for the existing programming languages, the LSP is a separate program from the actual compiler and everything, right? Which means that sometimes the LSP, the developers of the LSP are separate people from the people that are actually implementing the compiler, kind of. And they sometimes need to do the same work twice. They sometimes are lacking the information that's available to the compiler, which is making things more difficult, you know. But for me, the compiler, the interpreter, everything is like the same, like binary, which so like the LSP can interpret code, it can compile code, it can do everything that the compiler can. LSP is part of the compiler, which is something that is normally not the case, I think. Yeah. I wouldn't say it's difficult. Yeah, like it's a second compiler. As far as I'm aware, like for example, there is a programming language called Zig, right? They have the LSP, which is separate from the compiler, and Zig is a language which has compile time evaluation. So in order for the LSP to be able to figure out what things is, the LSP must be able to evaluate code at compile time, which means that basically the LSP should be a compiler. So why are they separate projects? I kind of don't really understand, because making them a single project makes things a lot more easy. But at the same time, it means that making the compiler means that also you need to make the LSP like at the same time. You need to like support two things at the same time. You cannot just improve the compiler without improving LSP, kind of, right? So yeah, there's that. Right, in Rust, the Rust analyzer, it can like the Rust analyzer, it doesn't do like a lot of like compile time evaluation, but one thing that it does, for example, is the expansion of the macros, which is very similar to compile time evaluation, right? So the expansion of the macros is implemented in the Rust analyzer I guess separately from the compiler, which means that it also means, by the way, that it must be done twice, which actually I think slows things down, potentially, right? Like, why do you need to do the same work twice? That makes no sense to me. We should only do things once. That's how we make the things faster. Yeah, but it also does mean that right now I am like when I'm just compiling and I'm not interested in the language server, I am technically still like having extra data which is only used in the LSP. So if I am only interested in compiling, then it does extra work that is not necessary, right? Which slows things down. So maybe like somehow you can make it optional. I don't know. But I don't know. Like have not hit the performance issues yet. I am expecting to hit them at some point when I start working on actual like big projects in my own language, but it's not there yet. We'll see. But yeah, making the LSP is just following the protocol. Protocol is relatively simple. You just get the request, hover in this position, and and like you give it back what is under the cursor, right? To have this functionality. It's not difficult to do if you have all the information, right? Why the OCaml for the compiler though? OCaml is compiling really fast. I was using Rust before. This is a rewrite number 3 of this programming language. OCaml is really fast to compile. OCaml has a good enough type system. So I don't know the other alternatives that I would be considering basically for making a language is either Rust, which I was writing this before in, but then I hit this super slow compilation times, which is why I switched to OCaml, or Haskell. So it's one of those 3. I didn't really consider other programming languages because I like having a good type system. But there are some other potential candidates. Maybe. What would you use? Do you... I don't remember. Do you make your own programming language? What do you use? Like, I would for sure not use something like C. C is too much manual work. I don't want that. I want a high-level language, not a low-level language. Because I don't want to be bothered with the details, with the low-level details at this point. Because I'm making, like, a prototype right now. Yeah. All right, let me see. What am I doing? I have the evaluated expression, which means that potentially I should be able to hover it. So why am I not? Why am I not doing that? You're making your own in Zig. The only issue you're having is the LLVM silent failures. Yeah, so like I think I would not be using Zig. Zig is also a lot of low-level details which are unnecessary. And also, like, I think LLVM also is an unnecessary detail at this point. When I'm making the prototype, I'm making an interpreter. LLVM is in the plan, but it's not the most important thing. Like, I'm not focusing on the native backend right now. I'm not focusing on the performance of the compiler right now. So Zig would slow me down. And Zig is having a lot of, Zig is good at doing low-level stuff, but I think it's really bad at doing high-level stuff, because the type system there is pretty basic. A lot of things are too explicit. Comp time is not enough. How do I figure this out? I want to maybe like log the things that I'm considering for hovering. I actually like study my own code that I have written like half a year ago. So when I'm trying to hover this thing, I'm going for inner compiled, and then I'm hovering all of the inner things here, right? I think what I need to do is compiler dot, I think like match kind with expression. So if I say an expression, I just want to log it, you know, log info. And I mean, OCaml has a lot of issues too. I complain about it all the time, so whatever makes you happy, use that, I guess. Until I make my own language, then my own language will be the one that everyone should use, of course. Considering for hover expression print with spans filed. Okay, that's what I want to do. Cast restart language server. Let's open hello world. So this hello world, this is my output. Hello? Oh. Ports. Postgres. I don't know why I even have it. So we have cast language server over here. I'm hovering. Okay, so this is what I was considering, right? This is everything that I was considering. I'm considering the entire thing. And then I'm considering just the use.star. And for use.star, I'm considering this constant, which is std prelude. And then it's hover result. Okay, so yeah, it's not considering the this thing as an expression. It's already a calculated expression is the only thing that it's considering. So that's the problem. Ever thought about making casting cast? Yeah, that's like one of the short-term goals, relatively short-term goals, and by short-term, maybe like in the if I can do it in 1 year, that would be good, you know. But like, what is a requirement to rewrite the language in itself? It should be not like completely like unenjoyable to write the code in it, right? So it should have enough of the type system. For me, it should have enough of the editor support, which is why I'm focusing on the LSP. Like, if I was not having the LSP at all, I would not be considering rewriting casting cast at all. Because that's annoying, right? Because when I work on my code, I want to be able to go to the definition. I want to be able to rename things all the time. These are the two most important things, I think. So, yeah. So just for code navigation, that's what I use the LSP for, right? And for renaming things, because like you refactor all the time. And the renaming is the most important refactoring, which should be done automatically, not by like just find and replace. Auto-completion is another one, which is not working very well right now. But auto-completion, I think, is lower on the priority list. It would be really nice to have, though. I have some form of the auto-completion right now. I need to like figure out how to make it better. Not sure if the debugging support is very nice. Debugger is... I was considering looking into the debugger. It's probably not that difficult to make. Maybe I will look into it today, actually. There is this thing that is called the DAP protocol, similar to the LSP. There is the debug adapter protocol, which is the thing that is like LSP but for debugging. And if I implement the DAP, then I should be able to use the existing tools in the VS Code and Vim and whatever to debug things. But I never looked at this thing. Maybe I should. I don't know. Also, like the short-term goal is to just be able to do the Advent of Code, which starts in 10 days, right? Just to try using the language for something. Right. I already did it a year ago, but then we have rewritten the language 2 times since then. Inner compiled. Wait, so wait, hold on. I'm just saying find map. The one that's inner, right? Hold on a second. I want to bring back the logging. So I'm considering this thing. And then since I have found the result, I will say found inner result. What's the result? Cover info. And then if none, then did not found no result. Okay, let's try that. Oop. Consider for however then. Consider for our use. Consider for our const. Did not found, but then found. Okay, so here's the thing, right? So we have the constant. Necessity prelude. Oh, wait. I think I know why. Hold on. Core syntax. Let's look at the use.star again. What is this used expression? I just evaluate it. No. I evaluate this thing here immediately when compiling. Find the bindings. I return use.star. And we have a constant expression used. Okay, that's the thing. That's why we have the... That's why I was considering the constant. So for the constant, I did not find the inner result. But for use.star, I did find inner result. Okay, let me take a look at this code again. Okay, so this means that I am covering the constant. That's what's happening. I hovered a constant. Right? I hovered a constant. I think this expression constant that I have has the span of the entire thing. That's right. Even although this constant is like... is a different thing. Hold on. I feel like I don't care about this. But I still need to give it some span. Like, I need to give it a fake span so that I cannot hover it, basically. Because so what's happening is we have the expression std prelude, which is me having the field access to the std, right? But then I actually evaluate it, and then we have the std prelude as a constant, which also has the same span, which is why I'm hovering it. And that's why I have in my hover like the value. So yeah, I'm literally hovering the prelude here. But the span is the entire thing. That's what's being highlighted, because that's what I evaluate, initialize the span here too. Dun, 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 dun. I think I know why, though. I think I actually know. I think the evaluated... okay, I just need to do this. Evaluated expression needs to be over here. That's all that I need. Because I evaluated the used expression to get this constant, not to get the entire use.star. Which means that this is going to be the inner expression of the constant, and I will be able to hover it, I think. So I don't even need to remove that, actually. But the span here is going to be the span of used expression dot data dot span, actually, I think. Not the span of the entire use.star. That may work better. Let's take a look. So now if I hover like use std.star, like if I hover over here on the dot star, this entire thing evaluates to nothing. So that's why I see just a unit here. But then when I hover on the std prelude, then I see the prelude. Okay, and then if I hover on the std, I can hover, I see the entire of std here. And then I can actually go to the definition here now. Okay, nice. Nice. This is just some logging, which can be discarded, and then this is what actually is fixing hovering for use.star. Okay, that's a good thing. Let's see what else can be improved. So so one of the things that can be improved, what is std prelude right now? If we look there, well, first of all, it gets me over here, right? Which is how we do it. So a prelude is just included in another file. One thing that I think want to be able to do is to, since I'm including another file here, I want to be able to go to this other file. So I think being able to go to the definition on the include expressions should get me to this other file, right? Because right now I will need to like search for them manually. That's one thing to improve. And then there is another thing to improve, which I will do later, which is actually the prelude. As you can see, this is what prelude contains. It contains a lot of like repetition, where I'm just creating a new constant called print, which is just equal to the IO print. So in the hello world, if I go to the definition of print, I go to the definition inside of the prelude. But I think what I want to have is I want to go to the definition of the IO print, which is the definition of the function, actually. And not the definition of just the re-expert. And for doing that, I think what needs to happen is I need to have like use IO print. So right now I can only use dot stars, but I want to use specific symbols. That's a thing, right? That would be nice to have. Let's first work on go to file though, that I am including. I have two things actually. I have imports and I have includes. So here is an import test, import 0. Over here I'm importing a 0 file, and I can also not go to the definition. There's imports and includes, and both of them I want to be able to go to the file, right? So how would I do that? Let's see how find definition even works. So I have the hover info, and then I have the definition. Which is hover info.rename. But the files, they should not be able to be renamed, should they? So right now, this hovering, this thing is just used for renaming. But but for the files, I mean, for the files, renaming the files kind of actually does make sense, right? Like if I rename this, then it should rename the file itself. Actually, but that's a different thing. Let's for now do it completely separately. So on the hover info, maybe I want to have like file. The file that I'm hovering basically, right, is a URI option, then, right? Something like that. If I'm hovering a file. Okay. If I'm hovering a tuple, this is for tuple fields, right? Over here, file is none. If I'm hovering an assignee expression, then file is going to be none. If I'm hovering a pattern, then file is none. If I'm hovering a type expression, then file is none. Well, I mean, actually, you know what? When I have the include, when I have an include, what actually happens? Let me see. If I do core syntax, include, what's happening then? Because I have the path, right? I just compile the included thing. The AST is the AST of the included file, yes. File is included. And then the compiled thing has evaluated expression, which is this. So maybe like my data, my data that I have right now for every expression, this is what I'm storing. Evaluated expressions and type descriptions. So maybe like one other thing is if this was included or something. Because I don't actually have the an expression which is include, right? Yeah. I think somewhere over here it should be like file included, or I guess included from file is going to be URI option, right? Is this expression included from a file then? And then over here I say that since I have included a thing, right, then I say included from file is some, the file that I was including here, source Yuri, so there is literally just some Yuri here. By default, for all of my expressions, I say that included from file is none. Right? But when I import, so the include I think is already done, and then I have the import. And for import, I have this Yuri here. So we have the imported value, we have the constant. So we initialize expression here. I initialize it and then I update data. Where was I? Over here. So I just say compiler, update data, find const, function, data with included from file is some Yuri. And that's all that I need to do. And then in the LSP, when I'm hovering an expression, hover specifically, file is none. Hover info. How do I do that though? It's almost like I need to do it separately. Maybe I don't actually store it in the hover info. Where do I store it? So like right now when I am including here, right? This is a string. That's what I'm hovering. but then the included from would be attached to this node, which is like a constant. Actually, why am I not hovering it here right now? That's weird. Include is over here. Like I'm creating. Oh, because the thing is having a different AST. Yeah. It's literally is already in another file. Because that's not an import. Okay, that's fine. But it also means that I'm attaching the thing to the wrong thing, I think. Yes. I think this evaluated expression then, which is the path expression, that's what I want to attach the included from file then. Yeah, so path expression is this, and then I also say that path expression after this. I say path expression is compiler update data. Expression, path expression, data with this thing, which means that actually the string is what is going to have the attached included from file. So it's not included from, it's the included, it is just the included file. What I want. Okay. So then in the LSP, I think when I'm hovering specifically something, which is what I'm going to be doing, I just say that file is included file. And the included file is going to be here. Let included file is compiler get data of kind compiled dot included file. That's it. Yeah. Okay, maybe that's all that I need. Let's see if that works. It doesn't work yet because I'm not using the file from the hover information. So what I want is when I want to find the definition, right? When I want to find the definition, I have the hover info. So I'm going to say over here, I'm going to match hover info dot file with some file. Then it's going to be something, and in other cases, I'm going to do these other things. So if I'm hovering the file that's like included or whatever, then I want to return this file, location, location is going to be the URI of which is the file. And the range is going to be the span range. So span dot beginning of file. I think that's where I go. Let's see if that works. Okay, it does work, but it seems like the is this a feature of the VS Code? So it can go to the definition, but it's highlighting the this thing. But it should, while it should highlight the entire string. Maybe. Find definition. Yeah, because this is just giving me the definition. It's not. And then it just gives me the position. So there is no information that I'm giving back to the editor of what I'm hovering. Now let's take a look at the LSP specification. Find definition. Definition client capabilities. Text document definition. The go-to definition is sent from the client to server to resolve the definition at the given text position. The result application link. Request parameters is this. Response is location or location link or null. This makes no sense to me. So this means that I cannot tell the editor to highlight the entire string because the request only contains the position of the cursor, not a span, and I don't give it the span back, only the span of the definition. Feels like they could improve the LSP protocol itself. But I mean, it works, and that's what matters, right? Yeah, I can like control click over here in the beginning on the quote, and then I go to the prelude. Hello, standard pointer. This just feels wrong because how does VS Code figure out what am I actually hovering here? And I guess this is not a problem in Vim because in Vim, when you go to definition, you don't see the highlighted thing of what are you getting to. Hello, Nigel. Yeah, I can... so here's what I did, Nigel, just now. I can go to the included files now, but it's highlighting the thing a little bit weirdly, and I don't see any API that I can improve that, but that's fine. At least it works. I can go to the included files, and I think I should be able to go to the imported files too. I did not try that. So in the import 0, so over here I'm importing a 0, and I cannot go to the 0 here. Okay, let me fix that too. Oh wait, I can, but I need to hover the import here, not the 0. Okay. Fine. Let's do core syntax. I have the import over here. The included file is here. But I think I do it literally the same for the path expression. I'm updating the included file to be the URI over here. And then I just don't update the data here. I do that. And then import 0, this should work. There we go. Okay, so that works. Go to included imported file. All right, and the next thing, like I said, I want I want, when I go to the print here, to the definition, I want to go not to the re-export, and I want to improve this in general anyway. What I want is, instead of saying const int32 is int32, I want to say use int32, right? Which basically is not introducing a new symbol, it is reusing the existing, like, symbol thing. It's just a re-export, right? That's what I want. So all of these consts should just be use, like this. So this is different from use.star. So I don't even have the syntax for it right now. Let's see, syntax rules. I have use.star, but I should have a separate thing which is just use. So just use a thing without a dot star, and that's just use. Okay, so this is now parsed as syntax, but I need to implement this for syntax. Use dot star. Let's copy that into just use and see what needs to be done. So when I use, I have the used expression. The use expression, which I am trying to evaluate here, but that is wrong. That, I think, is actually wrong. Because a used expression what should happen here is I should only evaluate IO and then print is its field, which I should like re-export. I mean, no, I kind of evaluate this. Sure, but it's not any expression can be used here, right? And to like extract the thing. So it's one of the two things. Well, if we don't look at this, it's basically something like use, or it should have expression and dot field. Basically, that's, so this expression can be anything, but and then this field is what I'm exporting, and then in this case we just re-export something that's already in scope. So it's not a field of something. But just a thing. And that's a little bit different. Okay. But I think what should happen is I should not evaluate this expression, but I first should just compile it. And then after I compile it, I see if this is a field expression or if it's not a field expression. And if it's not a field expression, then it must be just an identifier. Just a binding. Yes. Okay. I guess I just do this from scratch, right? So used expression is compiler compile c.compile. I'm compiling an expression. I give it the AST. AST is AST. No, not AST. Used. Yes. So this is a used expression. And then I'm going to match used expression dot shape. So it can be an expression binding, which is the simple case, right? Expression binding just has a binding inside, right? So that then what I am doing, what am I doing? So I kind of like wanted to just rewrite the use into the same thing that I did before, where, you know, like const used is used, basically. Right? It's just the same, which it should just be the same, like symbol and stuff, I think. Yeah. So what is that? Const. Const pattern value. I need to do something similar to this. Which is assigning to a let pattern. In this case, pattern is just going to be a binding to. Let's see. So I have I basically return an expression assign, right? I have an expression assign. Initialize expression. This is state. And I assign assignee and value. Assignee is going to be assignee binding. into init assignee. Used expression span. And value is the actual thing. So I should actually, oh wait, I should actually evaluate it then still, right? Yeah, I should always evaluate it. I just should figure out the name. This binding should not be the same binding. Yes. I should create a new binding. That's what I want. I literally want the same as const. I might want to... I don't want to copy paste this. I kind of want... this part to be exported into a function. So let's do this. Const expression. Constlet. Constlet just needs basically a pattern and a value. And module C, I guess. Right? So then I have a let const let be equal. So I have a pattern value. Pattern value. And module C, which is compiler. I also need the value expression. Value expression. Maybe I just give it value expression. Then value can be calculated inside this helper function. Like so. Where's the syntax issue? 973. What's the span here? This is the assigning. This is the span. This is the span of the entire thing. Okay, span. Sure. That should work. Span, pattern, value expression, and compiler. All right. So then over here, I just want to return and to like initialize pattern to something and to figure out the pattern basically. This is where I do it. Let pattern be mesh use expression shape in and this over here is just going to be const let span pattern used expression module C. Yes. So I just need to figure out the pattern here. That's it. So if we have a binding, then the pattern, so pattern must be a pattern, right? This is going to be pattern binding. Pattern binding. I need to create a new binding though, right? For sure. Is there a binding? Create? No, there is not. I should just do that and then initialize pattern. Use the expression dot span data span. Need pattern. See state. This should have inside a label to be the same as existing binding label. That's the most important thing, right? That I should do. And then I also should say that type, or wait, like what do we have in the binding? We have name, span, type, and label. Name, span, type, and label. So name is going to be a new symbol. That's going to be a different symbol. Symbol create using existing bindings name. Type is going to be equal to this existing binding. Span is going to be binding span. So, and label is binding label. So the only thing that I'm doing differently is I'm creating a new symbol, right? So binding with name being a new name. Okay. If it's anything else here, I should do error. Span. Cannot use expression print. Is there print short? Only for ASTs. Cannot use this. Let's just do that. And then I just return then the pattern, which is a placeholder. I guess initializing the pattern can be done for all of the cases anyway. So this just return a placeholder, and this is returning a binding. So this is pattern shape then. Okay, so right now I should be able to use the bindings. Let's just try that. So I can say, so this is still. Let me copy all of that. Undo. Do this. So this is what it worked like before. So just these two, which use a dot, are not going to be working right now, but this should. I mean the other way. This should be uncommented, and this should be like that, right? Because this is just using the binding directly. Restart language server. Seems like that works, right? I cannot go to the definition here though. Maybe I need to like add some information here. But what if I go to the hello world? So I cannot do print, but I can do like int32, right? If I go int32, what is int32? Int32, if I go to the definition, is now the actual int and not the re-expert. Right? I go to the actual definition now. Okay. But what happens if I want to... whatever, let's just finish this first. I want to do that. So this just is going to say that this cannot be used, right? Because this is not just a binding, but a field expression. So that should be able to use that. So expression field. Expression field. Then it's going to be... I mean, it still is going to be a binding. Right? We just don't have existing binding. We will need to create a new name. And we have for the field a label. Right? So we have object, field span, and label. So I create a new thing here. Span is field span. Type is used expression. Type and label is going to be the existing label so that we can rename it properly. This is just a string. So that's what the field is, I guess. And object, I don't like really care about the object here that I'm using because I'm just going to evaluate the entire field anyway. Okay, I think this should just work. Restart language server. Let's go to hello world. Print. If I go to the definition, this just goes to the definition of the function now. Okay, nice. Now, now here's the important question: what happens when I rename? Because well, I guess let's try it locally first over here, right? I will say something like this: const foo is use foo, and then over here I say foo is a function x returning x, whatever, right? Then I say over here foo dot foo, right? Const foo is module, right? So foo is a thing that has this. If I go to the definition, now I used to go to this. If I rename this to foo2, wait, it actually does rename all of this? Okay, it actually does. I thought it would not work, but it worked. Foo field. Okay. That works. Okay, and if I use inner dot field where I say that, I don't know, inner is dot field, right? Let's see what happens then. This doesn't work. Okay. I mean, wait. It almost worked, actually. Wait, I know what happens, actually. What happens is this over here is a shorthand syntax. Because this is short for dot field is equal to dot field, to field. So if I rename this to field 2, I rename only this thing, which still has got two twos here for no reason. Let me just commit what I did. Use without dot star. Okay, yeah, I had this problem yesterday too, right? Which I did not fix. Sometimes I am doing this twice. The edit, I guess. So the question is why? Question is why? Do I log? Rename reply, yes. So here's what we do, right? No. Rename reply. Can I clear this? Clear output. And then I want to rename this to field 2. Okay, there we go. So we have a new text field 2 at line 9. Character 9. Character 4 to 9. So this thing was renamed. Line 7. This is using 0-based indexing. And then at line 6, as we can see, yeah, so this is the problem. I have I given it the same change twice. Why is that? Because the reference was there twice. SP over rename. Rename is this. We have the definition. Yes, okay, maybe it's because of this. We have the definition span and definition references. Can it be that this span and the reference label definition. So here's what we do, right? We say that span is label get span and references data references. Let's try logging this thing. So yeah, definition span is this. Line 7, 21, right? And then references contains this thing itself. There you go. That's the issue. That is the issue. And why is this the issue? I actually know why this is the issue, because this is an anonymous struct. That's why. Yeah, that's right. I had issues with anonymous structs. With anonymous tuples. Which I did not create the type for first. Which means that this is just a reference. It's a label which doesn't have a definition. That's the thing. Yeah, because label get span gets either the definition or reference. This gets like any span, which can contain the references too. Find the definition, but yeah, what I yeah, that's what I should think about. Where is the definition? Because this thing might be the definition, but not necessarily. Okay, I think I just actually fixed the renaming. Which means that I do something like this. References. Let references be equal to if some span is equal to references list head opt, then references list tail, because I'm always getting the first one. It's kind of a little bit of a hack. Tail, else I just keep references as is. Actually, I just have the data here, right? Let's see. Let span and references be match reference, match data definition with some definition, then definition and data references. None, then it's going to be list head data references and list tail data references. Let's see it again. If I see here, failed too. There we go, now it works. Now this works. Nice. I'm going to need to take a quick break in a second. Fix renaming labels with no definition. No tuples. The back. All right. So everything works. What do we do now? Now that everything works. Very well. Do I try actually writing some program? Maybe I should improve the guessing a number game. Or do I work more on LSP improvements? Oh, yeah, okay. There's I was thinking about doing the debugging. Doing a debugging would be nice. But wait a second. I see an issue immediately as soon as I open guess a number game. I cannot hover things anymore. Why not? Why not? I don't see anything here. Wait, this doesn't work at all. I have formatting and syntax highlighting, but I don't have any. Other LSP features, which was working before for sure. Is it part of the workspace? Yes, a number, it is. I mean, I wouldn't have the syntax highlighting here if it wasn't. Okay. What if I delete all of this? Then I can go to the prelude. Okay. I guess it's because it fails compiling, maybe, potentially. Let's check if it runs. Cast run examples, guess a number. Does it not work? It doesn't work. Okay, that explains things. Tried uniting different labels. That's what's happened. I actually am panicking. Okay. While compiling this thing, while compiling this thing, while compiling less than. Picked less than guess. This thing did not compile. Okay. Fine, let's see what's problem here. So if I just say a 1 less than 2, then nothing is working anymore, right? 1 less than 2. There we go. So what's the problem with less than? I think I know what is the problem. It's my to-do things. Right? Or is it not? Let's see here. Tried uniting different labels. Let me log the labels here, right? Labels. This and that. A name, B name. Fail. Okay, I tried two different labels, empty and 1. Wait, I have an empty label, and label 1 means the so this is the field number 1. Field number 1, okay. Let's see label. Let's see label create. Either definition or reference. This is probably the thing. Because we have a native function, right? Then maybe in the core syntax, label. I can figure out the spans in this log in this logging. So we do a dot get name a, get data span a, span print this, and span print that. Get span is this into get data span, and let's get data span. Data is this. Okay, so one of them is over here. Okay. So this has an empty label. Tried uniting different labels. An empty label over here and one over here. By the way, this is the first thing. Shouldn't the first thing be 0 and not 1? That's weird, but this is the unnamed field. Less. This is because syntax AS. Well, we implement syntax A less than B using stdcmp less A and B. Okay, so is it the core syntax tuple stuff? Tuple field label, create reference label. What is label? Tuple field. This is if it is that, and if it's not, there you go. This is the empty string. There you go. Label is empty string. This is wrong. Of course. I didn't even write it to do here. Okay. So in this case it's that, and in this case it's going to be the index of the field, right? Let unnamed index be 0. In this case, it's going to be int to string unnamed index. But I am going to say that unnamed index named index +1, like this. Okay. Oop. So now we tried uniting different labels, label 0 and label 1. The question is, why is this? No, this over here is label 0. That makes sense. And why is this over here label 1? That does not make sense to me. So I have impulse syntax A less than B. CMP less. A and B. Let's first try this. STD CMP less 1 2. Does this work? This also doesn't work. Okay. So we have the label over here is 0 because this is the number 0 field, and this over here is 1. Okay, but why is that? That makes no sense. And why was the label even coming from? Because this over here, if I did an empty, right? It means that this 1 is coming from somewhere else. Where is it coming from? 1. Is there such a thing? There is such a thing over here and over here. But that is not what is wrong. Where am I creating the labels for the other ones? It's isn't it also supposed to be comma impl? Is it when I'm initializing expression? Tuple label is field label. Type tuple field label. This does not make a lot of sense yet. Dun, 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 dun. Okay, you know what? I'm going to figure this out later. Like I'm not feeling well. I'm just going to end the stream here. Maybe we'll come back later. Today we'll see. Guys, later.